Hi everyone, this video will introduce you to sampling distributions, which comes up in Chapter 8. These are the slides for Chapter 8. The slides have some background, information about formulas, and it also provides some examples. In the lecture notes, I wrote some different examples, but they're very similar to the ones in the slides and similar to the ones you'll see on the homework. What we'll focus on in our class are sampling distributions of the sample mean. There are a whole bunch of different kinds of sampling distributions, and I've listed a few of them here, but this will be the main one we focus on, distribution of the sample mean. And a distribution of x bar, the sample mean, is a distribution of all possible sample means of sample size n, of a certain sample size. So why would you need to study sampling distributions, and what's the meaning of them? Well, here's an example. Suppose that you're a biologist for the U.S. Fish and Wildlife Service, and one of your jobs is to monitor the acidity or the pH of a remote lake in Idaho. The typical, or the population mean, acidity of this lake is 8.0. Every week you measure the pH of water taken from 30 randomly selected locations in the lake, and you calculate the sample mean pH, this is x bar, from these 30 measurements. On some weeks your measurements may result in a sample mean that's slightly below 8.0. So for example, let's say that on week 1 you get your 30 measurements and the mean pH that you get is 7.7. Or maybe like on week number 8 you get your 30 measurements, you calculate the mean pH and it comes out to 7.9. So that can happen even though the typical pH of the lake is 8.0. It can happen that you can take a few samples and then you find the mean and it's not quite 8.0. It might be something below it. And the same goes for on other weeks. You might get measurements that result in a sample mean that's slightly above 8.0. So let's say that on week number 3 you get your 30 measurements and the mean pH turns out to be 8.2. Or on week 16 you get your 30 measurements and the mean pH comes out to be 8.1. So again, that can happen even though the pH, the typical pH for the lake is 8.0, on any one particular sample you can get a different mean by chance. So after many weeks and after recording many sample means, you might start to form a distribution of all of your sample means, and it might look something like this. So you'll start to form a distribution. 8.0 would probably be the most typical sample mean that you get, but you might get sample means that are slightly above, slightly below. Those are also pretty typical. It would be more unusual to get a sample mean that's far below or far above the average of the lake. So all of these represent different sample means. So as a biologist, if you get a sample mean that's slightly below or slightly above the population mean, that shouldn't concern you. That's very common. You can get sample means that are just slightly above or below the population mean. But let's say that on one particular week, your measurements result in a sample mean that's far below, or maybe even far above, 8.0. For example, let's say that in week 22, you get your 30 measurements, and the mean pH from that sample is 6.2. If you got a result like that, that would be quite concerning. And why is that? Well, the reason is that using a sampling distribution of sample means, you could calculate the probability of getting this as a result, of getting a sample mean of 6.2. And if this was our sampling distribution, 6.2, a sample mean of 6.2 is way on this side. It's way on the left part of our distribution curve. And that means that it's very unusual. It would be a small probability of getting that for a result. And if you get a result that has a small probability, that indicates that something is changing in the lake. In this case, if you're getting a very small, very unusually small sample mean for the pH, that is showing that perhaps the lake's acidity is actually declining. Alright, in the next video, we'll move on to some calculations.